So animation principles, this particular PPT, I have taken it from the internet. Hopefully you are able to see the screen. So what is the outline? So outline is we are going to learn principles of traditional animation, then animation, and how to create on the animations. So what are the principles of animations? So again, last time I think we have talked this in pretty much detail. The principles of animation. So animation is possible because of a biological phenomenon known as persistence of vision. So this you have to always keep in mind that this is one of the most important concept and the psychological phenomenon called phi. So an object seen by the human eye remains chemically mapped onto the eye retina for a brief time after the viewing. Combined with the human minds need to conceptually complete a perceived action. So this actually is making, last time we have discussed it, so I'm just repeating it again. So this makes it possible for a series of images that are changed very slightly and very rapidly, one after the other, seem like a continuous motion. So yes, so that is nothing but the persistence of vision. So what is animation actually? That we have to understand. So we have actually started with the second unit, and it is nothing but the introduction to animation. In the previous unit, we have seen the introduction to computer graphics actually. So there we have learned everything which is related to computer graphics, and animation is part of the computer graphics. Yes. So what is the animation? So animation is, it again comes from the word as animate. Generally, most of the words are coming from, the like computer is coming from compute. So like that, animation comes from animate, which literally means to give life to. So it is nothing but giving the life to something. It is actually called as animation or animate. So animation is nothing but moving something. Animation is moving something that cannot move on its own. So yes, of course, something which cannot move on its own, we have to move it ourselves. So of course, that is called as animating. Yes. So animation adds to graphics the dimensions of time. So actually, we are adding some kind of a dimensions to the graphics, and which tremendously increase the potential of transmitting the desired information. So through the animation, actually, we are trying to convey many things to the to different people, and that is why today animation is used so vastly everywhere. Is because of that reason. So in order to animate something, the animator has to be able to specify directly or indirectly how the thing has to move through the time and space. So yes, by using various techniques, the animator, a person who creates the animation, is called as an animator. He should be able to tell how the things are moving through the time, through the space. So like that, he has to create that. So there is something called as a 2D animation, and there is something called as a 3D animation. So under 2D animation, there are two types. There is a cell animation and path animation. So let us see what are those. So everybody knows what is meant by a 2D animation and what is meant by 3D animation. Yes. 2D means two dimension means we are able to see all the cartoons, previous cartoons which were 2D, and everything was flat surfaced. Whereas in 3D animation, we are able to visualize from all the dimensions a particular object. Yes. So that is what was the difference between 2D animation and 3D animation. So here under 2D animation, we are again having two types: cell animation and path animation. So let us see what are those. So what is mean by cell animation? So now this cell animation was made famous by Disney. Uh, so in the history, we have seen that Disney have created some important things related to animation, and so they have made this cell animation was made famous by Disney. So there are 24 frames per second. Therefore, a minute may require as many as 1,440 separate frames. So the speed of frames or the frames per second are being shown here. So in the cell animation, we are using 24 frames per second. So you can imagine uh, in a minute we are aroundly showing 1,440 separate frames. And as these frames are moving so rapidly, it creates the illusion of movement. So cell animation is based on changes that occur from one frame to the next. So of course, each frame will be different from the previous one. So yes, cell animation is completely based on the changes which are occurring from one frame to the next. Cell stands for celluloid. Why the name is given as cell animation? So cell stands for celluloid, which is a clear sheet with images drawn on them. So cell animation is where you are having a particular sheet which is made up of celluloid and which is a clear sheet where we can draw the images. Yes. The celluloid images are placed on the background that is usually stationary. Yes. Uh, Similarly, there is something called as a path animation. So path animation is where the moves an object along a predetermined path on the screen. So there will be a particular path which is fixed for the animation or the object, and this particular object will move according to a particular path. So that is generally called as a path animation. The path here can be a straight line or have a number of curves. So either we can have a straight line on which the particular object is moving, or we can have some kind of curved lines on which the particular object is moving. So like this, there is a path animation. So you have to understand there is a two different types. There is a cell animation and path animation, which are generally being used. It starts with the keyframes. Generally, this path animation starts with keyframes, the first and the last frame of an action. So there will be one frame that is called as the first frame, and there will be a last frame uh, along that particular path. The series of frames in between the keyframes are drawn in a process called twinning. So you have to, we'll see the examples of it. Of course, then you will try to understand. But right now we are just learning the theory part. So there will be one frame. Suppose at this point, there is we'll call it as a first frame, and there will be a last frame. Suppose at this point, and in between that, whatever frames will be required will be automatically drawn by using a twinning process. So there is something called as a twinning. Twinning is nothing but where we are trying to draw the in between frames. So what is twinning means? So twinning requires calculating the number of frames between the keyframes and the path the action takes, and then actually takes and then sketches a series of progressively different outlines. So in between whatever is there is being drawn by the twinning process. So we have to understand that. After that, it comes a computer animation. So typically computer animation means typically employs the same logic and procedural concepts as cell animation. So it is pretty much similar to our cell animation. You can usually set your own frame rate at 15 frames per second. A second, the animation may appear jerky and slow. Yes, a 2D animation can be acceptable alternative to the expense of creating video. So let us see. There is a 3D animation. So 3D animation is what? 3D animation involves three steps: modeling, animation, and rendering. So modeling is nothing but the process of creating the objects and the scenes. So here a lot of efforts we have to take in the 3D animation process. There is a modeling, the process of creating the objects and the scenes. Then there is another step called as animation, the process of defining the object's motion. And there is one more step, rendering, the final step in creating the 3D animation. Yes, so of course we have to in detail study all these things. What are these modeling, animation, and rendering means? But right now we are just trying to focus on all the terms which are generally used in animation. So in animation, there are terms such as cell animation, path animation, there is a 2D animation, there is a 3D animation, there is a computer animation. Similarly, there are some other terms which are generally used. You are able to see on the screen. So morphing is the process of blending the two images into a series of images. Warping allows you to distort a single image, and virtual reality creates an environment that surrounds the user so that they become part of the experience. So why we are seeing all these things? So these are nothing but the terms which are generally used in animations. Yes. So you may come across these different terms, and we should be able to tell what all these terms means. So next is animation techniques. So as whatever we have learned until now, that animators have used and invented a variety of different animation techniques. There are a variety of techniques which can be used for animation. Traditionally, most of the animations was done by hand. So previously also told you so many times that generally we are using, people used to draw images and then try to photograph it or copy it or make a film out of it. And most of the things are drawn through hand. So all the frames in the animation had to be drawn by hand. Since each seconds, just we have seen that you require 24 frames per second. So the amount of the work which is required to create a very small film also. Imagine that you are creating a 5 minutes or 10 minutes film, and you are drawing everything by hand. So you can just imagine that how much amount of work should be done. कारण आपण आताच म्हटलं की 1400 around 1400 frames are required for 1 minute. Means you can imagine, you can just multiply into 10, so it becomes 14,000 frames. So it is a lot of work people has to do to create animations. What are keyframes? So what are keyframes? So in this technique, a storyboard is laid out, and then the artist draw the major frames of the animation. Keyframes म्हणजे काय की आर्टिस्ट काय करतो, एक जो मेजर आर्टिस्ट असेल म्हणजे जो मेन आर्टिस्ट असेल तो काय करतो की तो की फ्रेम्स ड्रॉ करतो. म्हणजे आता आपण इथे जर बघितलं ना, तर सपोज आपण असं कन्सिडर करूया, हा एक बल्ब आहे जो की या पोझिशन पासून या पोझिशन पर्यंत मूव्ह होतोय. सो द आर्टिस्ट विल ड्रॉ लाईक these two frames only. One is this, and this will be the second. So we can call it as a this one as a first frame, and this one as the last frame, or this one as a first frame or a last frame. So after this, what happens is, in between that, what action is to be performed. So it is jumping like this, suppose. So it is jumping like this, suppose, and the other artist will draw something like in between what that particular lamp is doing, or lamp frames are drawn by him. So in between is uh, frames are drawn by someone else, maybe. Yes, so like this, the previous way of creating animation was there. Yes, and of course it will require a lot of time because the main artist is drawing this particular frames, key frames, and in between that, whatever frames are there are being drawn by some other animators. Now the previous thing that we have seen, जे ट्विनिंग आपण प्रोसेस बघत होतो, ट्विनिंग प्रोसेस याला म्हणतात. याच्या इन बिटवीन फ्रेम्स असतात, त्याची जी ड्रॉइंगची प्रोसेस आहे त्याला ट्विनिंग असं आपण म्हणतो. हे लक्षात घ्या. Similarly, there is a rotoscoping. What is mean by rotoscoping or rotoscoping? So generally, rotoscoping is a technique where images are copied from a moving video and into an animation. So here some images are there copied from a moving video into an animation. The animator draws the motion and the shape of the object by referring to the video as opposed to imagining in his head. So here he is referring to the videos, how the motion is being there, rather than whatever we see in the keyframe techniques or a twinning, that where we are drawing the frames on our own. So here from the video, the animator is trying to copy. So with the help of the rotoscoping, one can animate some complex scenes that would be hard to visualize otherwise. The disadvantage is that one will have to hunt for the exact video that one wants to animate. So yes, so it is using some kind of videos from which the animation is being captured. So that is one technique. Similarly, one more technique is motion capture. So what is mean by motion capture? Here we are using some kind of a magnetic or vision-based sensors which records the actions of a human or an animal object in 3 dimensions. तर आपण जे प्रिव्हियसली हिस्ट्री ऑफ ॲनिमेशन मध्ये बघितलं होतं, लास्ट स्लाइड जर तुम्हाला आठवत असेल तर जे आपण अवतार मूवीचं एक इमेज होती, ज्यामध्ये वन पर्टिक्युलर पर्सन वॉज हॅव्हिंग सम काइंड ऑफ अ डॉट्स ऑन अवर फेस, अँड बाय युझिंग सम काइंड ऑफ अ video or using some kind of a technique, they were recording the videos or checking the motions. Yes, so motion capture is nothing but the same thing, that we are using some kind of a sensors which are actually on the man's body, which are kept on the man's body, and they are trying to record all the things, the actions, that how he is walking, how he is running, maybe how he is crying or laughing, like this. So there will be various sensors which are actually attached to human or an animal or any other object, and they are trying to capture that actions, and generally it is in 3 dimensions. So a computer then uses these data to animate the object. So then this particular data, the movement, is given to the computer to animate that particular object. This technology has enabled a number of famous athletes to supply the actions for characters in sport व्हिडिओ गेम्स. आपण जनरली जे म्हणतो की आपण जे काही स्पोर्ट्सचे व्हिडिओ गेम्स बघितलेले आहेत त्यामध्ये वेगवेगळे कॅरेक्टर्स असतील किंवा तुम्ही WWE सारखे काही गेम्स आहेत किंवा फिफा सारखे आहेत किंवा क्रिकेट सारखे आहेत, तर त्यामध्ये तुम्ही बघू शकतात की जनरली जे कॅरेक्टर्स आहेत, जे प्लेयर्स आहेत, रिअल लाईफ प्लेयर्स त्यामध्ये घेतले जातात. सपोज वी कॅन हॅव अ विराट कोहली in the cricket, or maybe Ronaldo in the football, or maybe someone in the WWE. So what they are being done, so their characters are developed based on this. Their motions are being captured by using the sensors, and then they are actually put into game. So like this, the particular motion capture technique works. And many of the people, many of the games today have a realistic characters in their games. म्हणजे विराट कोहली क्रिकेट सारख्या गेम मध्ये विराट कोहली ते सगळे आहेत. आणि तुम्ही बघू शकता जेव्हा तुम्ही ते गेम खेळत असता की त्याच्या ज्या मुवमेंट्स आहेत त्या कॅरेक्टर त्या प्लेयरच्या, त्या सिमिलर आहेत रिअल लाईफ सारख्या. कारण का? बिकॉज दे हॅव कॅप्चर्ड इट फ्रॉम द रिअल लाईफ पर्सन. सो लाईक दिस द मोशन कॅप्चर system works. Okay. So motion capture is pretty popular with the animators, mainly because of some of the commonplace human actions can be captured with relative ease. So of course it is very famous today, and you are able to see that avatars and all the other movies which are created are, they are using these motion capture technologies. However, there can be serious discrepancies between the shapes or dimensions of the subject and the graphical character, and this may lead to problems of exact execution. So this was previous thing. आपल्याकडे आता खूप बेटर कॅमेराज आहेत, बेटर टेक्निक्स आहेत, त्यामुळे या सगळ्या गोष्टी आता काही मिसप्लेस होत नाही किंवा सगळ्या व्यवस्थितच होत आहे. प्रिव्हियसली when this technique was there, they were not able to capture perfect actions. Today we have invented so many things that we are able to capture a very small detail also. Today we are having such a high-end cameras, such a high-end computers, so that of course all this process are becoming really easy. Not easy I'll say, but really flawless. There is no flaw generally. We are able to see the movies and we are not able to point out a flaw in the movies. So that is what is happening. So motion capture is very important. One more another technique that is called as a simulation. Now this we have talked so many times. So what is simulation? Simulation, unlike keyframing, जे की फ्रेम्स आपण आता बघितलंय की जिथे आपण फर्स्ट आणि लास्ट ड्रॉ करतो इमेज, आणि in between images are being drawn by some other people. So unlike keyframing and motion pictures, simulation uses the law of physics to generate. So simulation मध्ये आपण लॉ ऑफ फिजिक्स वापरतो आहे. सिम्युलेशन आपल्या सगळ्यांना माहिती आहे की आपण खूप वेळेस एक्झाम्पल घेतलंय की फ्लाईट सिम्युलेशन्स आहे, किंवा मग तुम्ही मॉल्स मध्ये गेल्यानंतर तिथे लहान मुलांसाठी ज्या बाईक्स ठेवलेल्या असतात त्यांच्यासमोर स्क्रीन असते. That are nothing but again simulation, where they think that they are actually riding a bike, and then there are obstacles and so on and so on. Simulation is actually using the law of physics to generate motion of figures and other objects. So by using the law of physics, we are trying to generate the motions. We are trying to figure out how they are moving, Virtual humans are usually presented as a collection of rigid body parts. So there can be some virtual humans. So motion capture, where actually we are trying to copy the real human actions. Here, what we are trying to do is by using the uh, uh, by using the law of physics, we are trying to find out the motion, how the motion will be there. मग जनरली तुम्ही रोबोट्स किंवा रोबोटिक्स अशी जी बघतात तर त्यामध्ये हे लॉ ऑफ फिजिक्स अप्लाय होतात जे की आपण सांगू शकतो की रोबोज आणि ह्युमन्स यांची जी यु नो वॉकिंग स्टाईल आहे किंवा काही आहे ती फार डिफरंट आहे का बरं कारण की दे हॅव टू क्रिएट they have to create or they are using the law of physics for finding out the motion. So like this simulation is working. So these are nothing but the techniques. I think we'll see it again. So these are some of the techniques that we have seen. So there is simulation, there is a motion capture, rotoscoping, and there is a keyframes. So different techniques are there. Other than that, what we have seen is we have seen some of the terms which are related to the animation, such as virtual reality, warping, morphing. Then you are having 3D animation where we are having different ways. Here also you are having some path animation where object is moving along a particular path. Cell animation, celluloid is used where we are using sheets to draw on them. Yes, these are the types of animations. And what is actually an animation? Yes, so a lot of theory part it was. Are there any questions related to this? Yes, students, do we have any questions? Okay.